Traditional skyscrapers are typically held up by dozens of internal columns. These run through the building and leave the exterior walls free to be encased entirely with glass. But this tower has a tiny footprint and narrows towards its peak. Floor space is precious, and support columns would eat it up. So this is their innovative plan. To maximize the floor space, the tower's architects have decided not to use internal columns. Instead, they'll direct much of the structural support into a steel and concrete exterior frame called a diagrid, the largest of its type ever attempted. Knitting all this steel together poses a big problem for the tower's consulting engineers, Steve Bongiorno and Jamie Silva.
Problem is when you converge to a joint, now you have individual reinforcing bars that need to kind of connect and consolidate into a joint.
If you were to reinforce one of those joints with the standard rebar, you would have very little room.
Steve and Jamie plan to reinforce each diagrid junction with a precise amount of steel. If 3 or more diagrids overlap, the steelwork required simply wouldn't fit inside the building. To solve this problem, they've designed an ingenious junction called a node. Each node is made of huge slabs of 3-inch thick steel, covered with precisely angled sockets, loaded with super high-strength steel bars. The steel bars must be at an exact length and angle to slot into the structure's steel skeleton. If any bar doesn't align perfectly, the node won't fit, and the tower won't be strong enough. But with 31 perfectly designed nodes, every part of the building's exterior frame should channel the weight of the building down to the foundations. But making this a reality is a very tall order.